Okay, in this video I'm going to show you how to do the calculations for the IB Rocket Lab. And I just grabbed some students' data here, and I'm just going to make a data table. Right? Tables have lines around them. You could do this in Excel if you wanted. There it is. Here we go. Alright, and this is trial 1, trial 2, 3, and then you could say time in seconds. Right, and then what we're going to do is we're going to add on to this, we're going to figure out an average, and then we're going to figure out the velocity and the uncertainty, right? But the first thing we're going to do here is we're going to figure out the uncertainty of the velocity, right? Okay. So for uncertainty, what we want to do is, let's say for the low one, basically the uncertainty is equal to the high trial minus the low trial divided by 2, right? So it's the range of the whole thing divided by 2. So for the low, if you're looking at the low here, the highest one is 5.03, the lowest one is that, right? So I'm just going to do that. I'm going to go parentheses 5.03 minus 4.48. Right, divided by 2, and that's 0.275, so I'm going to say 0.28, right, and then this uncertainty here is high minus low over 2, right, so 5.58 minus 5.27 divided by 2. You can't see it. It's like that's the one place where the light is reflecting. That's 0.155, so I'm going to say 0.16. Okay. And then the high, there we go, it's a little better. There we go. Okay, for the high, again, it's going to be the highest minus the lowest over 2, so 5.78 minus 5.35 divided by 2. Is that right? Yeah, that's right. 0.215, so I'm going to say 0.22. And I know we're supposed to express these as one digit, so I guess on an IB lab I'd have to say that that's 0.3 and 0.2 and 0.2. I'm just going to carry 2 sig figs here. And then the super one is 5.95. Whoops, got put parentheses around there. 5.95 minus 5.60 divided by 2.18. Right? So there is my uncertainty. Right? And then it might be also good here to, so we've got the uncertainty. This is time in seconds. We're all good there, right? Okay. It might be good in our calculations if we have a reaction time. So let's just guess that my reaction time is like 0.2 of a second, right? I'm just going to guess, right? It's actually probably shorter than that, maybe 0.14 or something like that, but 0.2 is a nice even number. So I'm just going to go with that. If I take this, let's do for the low, right? Okay. The first thing I want to do is I want to average these numbers, right? So it's going to be 4.48 plus 5.03 plus 4.87. Yeah, those are the 3 velocities, right? And then I just divide by 3. And it's 4.79, right? So the average is 4.79 seconds, right? And then I'm going to add 0.2 and say that it's been in the air for 4.99 seconds, because I started the stopwatch a little bit late, right? And now with that time, what I can do is I can actually just use SUVOT, right? I'm going to use this notion that V is U plus AT, right? So at the top it's 0, right? And it's an initial plus negative 9.81. And then the time I'm going to use is half the time, because of course it goes up and it goes down, and it's at the top at half that time, right? So it's going to be 4.99 over 2. So basically what it ends up being is that U is 1/2 G times T, right? That would be sort of the overlying formula for that. So I'm going to go plus 0.2, so 4.99 times 0.5 times 9.81, and I get 24.5 meters per second. Alright, so my initial velocity is 24.5 meters per second from that. Right, so again what we did was we found the uncertainty, right? We averaged those, added what I thought the reaction time was, and that'll, it'll be different. I'm old and I'm slow, so, but there it is. So we get 4.99, and then at half the time. So don't forget to cut the time in half. Okay, 24.5 is still pretty fast. You can probably drive safely on I-5, right? Now we want to calculate the uncertainty of that, right? So for the uncertainty, we just set up a formula. If U is basically 1/2 GT, where G is a positive 9.81, then the uncertainty of U over U equals the uncertainty of G over G plus uncertainty of T over T. We've done this before. I know you know this, okay? And so all I'm going to do is I'm going to fill this stuff in. I'm going to assume, just for fun, that this is 9.81, and that our uncertainty of that is really small. And if it's 9.81, that means it's plus or minus 0.005, right? It's plus or minus half the smallest thing here. And I'm going to say that that's really, really small. So I'm just going to, and then it just becomes a proportion, right? So let me just show you. Let's look at the low that we just figured out, right? The uncertainty is 0.28, so I go 0.28 over the average, which is 4.79. And again, I don't know if we're supposed to use that or that, but I'm just going to use that because that's the raw data there, right? That equals the uncertainty. Whoops, I'm setting this up wrong. Okay. Let's try this again. Okay, this should be the velocity, right? So the uncertainty of the velocity is to the velocity, so 24.5 equals, and then I'm going to go 0.28, and again I'm going to go over the average, right? So 0.28 comes from here, and then that is over the average, which is 4.79, right? And now we're all set. We're going to go, I'm just going to calculate that. It basically ends up being this times that ratio there, right? Okay. The glare. Okay, so it's 24.5 times the ratio of 0.28 divided by 4.79, and I get 1.4. Right? So it ends up being, the final answer is that it's 24.5 plus or minus 1.4, right? Okay. Let me just do one more example here. I'll do one more example. Okay. Hopefully these people are coming into the lab, right? Okay, so let's look at the medium. Okay. For the medium, again, the first thing to do is to average it, right? All right, so I'm going to average those numbers. 5.27 plus 5.58 plus 5.49. Right, so I'm just taking those numbers, averaging them, right? Divided by 3. 5.45. Right, and then I'm going to add 0.2 because I think that, whoops, not plus or minus, plus 0.2, right? Systematic error. 0.2 seconds. That might be my reaction time, right? Yeah. And get 5, that I think it's in the air for 5.65 seconds because I started the watch late, right? And then essentially my velocity is V equals U plus AT, right? It was 0, negative 9.81, at half that time, right? At 5.65 over 2, right? And then I can calculate that. It ends up being just 0.5 times 9.81 times 5.65. Yeah. It's a 27.7. Yeah. And now I set up my my uncertainty. So the uncertainty of the velocity is to the velocity as the uncertainty of time is to the time. So this is what I'm trying to calculate, right? The velocity is 27.7, right? And then for the medium, the uncertainty was 0.16. So that equals 0.16 divided by, and then I'm going to use the raw time, 5.45, right? And now I'm set. I can just go 27.7 times 0.16 divided by 5.45. And then that one equals only about 0.81, right? So this is 27.7 plus or minus 0.81 meters per second. And I know we're supposed to write it with just one sig fig, so really I think we're supposed to write 27.7 plus or minus 0.8, like that. Whoops, you can't see that, right? So I think you're supposed to write it 27.7 plus or minus 0.8. Hope that helps.